Hey, hello everyone. My name is Erin. I'm the Business Development Manager over here at Forestry. Thank you for joining us for today's webinar from your office, from your couch, wherever that might be. So a little bit of housekeeping before I pass it over to Matt for the big presentation and the demo. So this is a Softry webinar. You should have a cute little GoToWebinar panel that you can either hide, but you can also use that throughout the presentation today to ask us questions and to engage with us. And then just a heads up, we also are issuing certificates of attendance. So if you didn't have that question in your registration form, because we added it partway through, don't worry if everyone attends, you will be getting one sent to you unless you explicitly told us no, you don't want one later on. So just wanted to take one other minute to introduce Matt. So Matt is one of Softry's support engineers as well as our training manager. He was looking forward to giving this presentation live to the NERCoffee conference this week, but given the current situation, that conference has obviously been canceled. So just a quick introduction to Matt. Matt is no stranger to the East Coast Forestry and East Coast road design. I grew up on the East Coast in New Brunswick. He is a graduate of the University of New Brunswick, and he spent a whole bunch of years getting acquainted with our RoadEng software, working at Interfor, Western Forest Products, and most recently, prior to joining Softry, as a consultant at On-Site Engineering. He's now back on the East Coast. And he's coming to you live from, I'm assuming, an office somewhere in his house in New Brunswick. So with that, I'm going to pass it over to Matt. He's going to talk to you a little bit about something that you can do to help you better leverage your LiDAR data and a new approach to forest road design for those of you who aren't actually actively designing roads now, but do have LiDAR. This could be something that might be of interest. Okay, Matt, over to you.
All right, perfect. Thanks for the introduction. And yeah, as Erin said, this is largely the presentation we were going to do at NERCoffee. And with that, for those of you that have attended some of our other webinars, it's going to be a bit different format. So usually we do a lot of demonstration-based stuff. For this, it's going to be slideshow heavy at the start, and then we'll do a demonstration at the end. So with that said, we'll get into it. And so our topic is using LiDAR to improve forest road construction. So we kind of have to cover what LiDAR is. So all it is high-res survey data. It's usually collected for a large area, usually collected aerially by fixed wing. Drones are becoming more popular now, so you can scale it down and have smaller packages done with the drone. Per unit area, it's generally cheaper than other survey methods, and many of you probably already have it or have access to it. So if you work at a large corporation, there's a good chance that you've purchased it in-house. Even if you're not using it for road design, there's a good chance you're using it for your tree inventories or something similar to that. If you don't have it in your organization, there's also a good chance that your local government has purchased it, saw the value and purchased it, and made it publicly available. So USGS has a pretty good database of LiDAR data sets covering different areas. Depends on the province you're in. Some provinces have pretty good coverages for Canadian and customers, and abroad I'm not 100% sure what the accessibility is, but it's probably pretty similar. So how does it benefit construction? By itself, it doesn't. It's just a bunch of points telling you where things are. What it does benefit you is if you combine those LiDAR data sets with the design software, it makes it really easy to improve your planning and documentation. Yeah, it makes it much easier than previous methods to produce a high quality design. So I think for the most part, a lot of forest industry persons on the flatter areas of North America anyway, tend to rely on their GIS software for a lot of their road planning. So they might look at a hillshade, click in a quick alignment, look at the profile if it's hilly, and move things around. You might even look at a wet area map. But with that method, the road's largely to be considered as a line, so it's not really considering it as a 3D object or surface where your cut slopes are going to interact with the ground, your fill slopes are going to interact with the ground, etc. Yeah. As mentioned, I grew up on the East Coast. I'm back living on the East Coast now, but I did a lot of road design on the West Coast, and when I came home, a lot of my buddies in the industry out here would say, well, we don't really need that here. Yeah, the comments varied a lot, anywhere from just our terrain simple to we just drop the blade and go, which personally really like that last one. Nothing wrong with a bit of enthusiasm, but planning is kind of the case of an ounce of prevention is better than a pound of cure. It's you can still drop the blade and go. You just take a step back, plan things out, so when you do drop the blade and go, you're dropping it in the best possible place. So I kind of covered it there. I do disagree with a lot of those comments. I think there's value in designing even if you don't have LiDAR. But LiDAR makes it a lot easier. So old methods in the forest industry, you were usually limited to either doing a hand traverse or total station survey to get your topo data. Coarse topo data that's publicly available without LiDAR is probably too coarse to really get a good design from, and like a higher accuracy RTK system is not much good in under canopy. So stuck with those two options. Hand traverses, they're fairly inaccurate just inevitably given the tools used. So you're dragging a chain through the woods, figuring out your turning angle with a compass, and figuring out your slopes with a clinometer. Clinometers can be fairly inaccurate, and if you're on fairly flat ground, being a percent out could mean the difference between the water traveling ahead versus behind you. So yeah, that's the limitations of that. Total station, much more accurate, but it requires specialized equipment. So you need a total station, a data logger, and you also need line of sight. So it takes longer, gives you more accurate data, but both of these are fairly labor intensive. They require a two-person crew and a bit of time. Another limitation of this is it only collects area along your survey data along the area of interest. So if you want to put the road here, you usually just survey along where you want to put it, get the topo data to go from. You don't get that landscape level coverage that you get with LiDAR, where you can say, oh, well, let's try it over here and see if that's better. You're stuck either going back out to survey or making it work with what you have. So new method being LiDAR, it is fairly accurate. It depends on the LiDAR, but generally it's fairly accurate. You get a lot more points per unit area. So with the previous methods, you're stuck with whatever the surveyor thought was important is captured. LiDAR gives coverage everywhere, covers a larger area, and as previously mentioned, you probably already have it. So with that, you've got your topo data already. It's collected, you just load it on your computer, and within a few clicks, you're ready to go start designing. So there's really not much reason not to use it. Even if you're doing something that's fairly simple, there's still value in it. It doesn't take much time to get set up. So I'm going to talk generally about the benefits of design kind of as an overview. General planning with a design software and LiDAR, it's easier to consider things like geometry, drainage, how much earthworks you're going to do, if you have any interference areas with a riparian area or a legal boundary or something like that, same with disturbance areas. And it's really easy to have a defined set of design standards and make sure that if you want to design a 80-kilometer-an-hour road, your design standards reflect that. So it gives you safer roads and also can be used to increase your cycle time. So vehicles don't have to slow down. Another benefit is estimating. There can be a fair bit involved in this, so we are going to loop back on that one. I think it's super important. And another obvious one that is really easy to overlook is the communication and documentation side of things. So if you put together a design, it's nice to have something to communicate with your builders and say, this is what I want it to look like. And then kind of everyone's on the same page. And also from a documentation standpoint, if you want let's say a seasonal in-block road and they build you a gravel superhighway, well, it's nice to have some documentation to fall back on that says, well, this is what I wanted. You gave me this. Maybe we should re-talk about what we're paying for here. So how it all works, this big cloud of points is LIS data, so raw LiDAR data. When you acquire it, it usually comes classified, so you don't have to do a lot of this. It's just kind of providing a background for how it works. So we have our classified data. We see the black points there. We don't care about most of the points for designing a road. Where your vegetation's at, it's not really important. What we do care about is where the ground is. So we care about the bare earth points, which are the black points. We take those black points, we turn them into a tin, so a triangular irregular network, and that tin is used to create a surface. So there's our topo surface. For the road side of things, as previously mentioned, we're going to consider the road as a 3D object rather than just a line. So we have our center line, and attached to that we have our cross-section geometry, and how the two interact is how we come up with a good design. So here we can see we've got a decent fill. We could figure out, okay, we want a certain length of culvert in there, capturing some drainage. We see we've got a decent amount of cut going on here, and we've got some fill on the either side. So we can use that to come up with a pretty good plan, get things so we're balancing that this cut amount gets flopped back into here, and make a quick road. That 3D view is great for kind of visualizing things, but a lot of the time, the way I design and the way most other people I know design, it's nice to break things down into these three views are the most commonly looked at. So we've got our cross-section view, and we've got our plan view, bird's eye view or map view of where the alignment's going, and then we've got our profile view. All these lines are attached to one another, so as we move something in our plan view, that's going to update in the cross-section view and profile view, etc. So we can get pretty formed decisions. We've also got this Project Explorer tab over here where we can keep track of things like costs as we design. So the general, or what we use the software to consider, it has kind of some overarching benefits to it. Big three right here, we've got reduces uncertainty. No one likes uncertainty. It can be really expensive. So you either end up overestimating or underestimating things if you don't know exactly what to expect. Overestimating, no one likes that because you end up ordering more culverts than you need or longer culverts than you need. Underestimating isn't good because, well, you don't have as much material as you need. So with the culvert example, you're either stuck going back, ordering another load of culverts, getting a few couplers and making things work with what you have, and maybe skipping culverts that probably should be there. So yeah, no one likes uncertainty. Another thing, these two go hand in hand, reduces indecisiveness and make better decisions. So having everything that you need to consider in front of you is super helpful to make better decisions. You can see what's going on. You can look at the costs as you narrow in your design and consider other options. And then being able to see that reduces the amount of time you spend sitting on the fence and humming and hawing on which way you should go with things. And circling back to estimating, so that's kind of part of having the informed decisions. I think oftentimes road construction is viewed as a fairly qualitative process. So things get lumped into being either difficult, so it's going to take longer to build, normal, take an average time, easy, we'll fly through it quick. You might also use a construction class system, which oftentimes is still fairly subjective. So using a software lets you move away from that. The drivers for road construction costs are how much and how far. So how much material you're moving, how much material you're excavating, how much material you're using as fill, and how far you have to move that material. So the software keeps track of all that because we're comparing the two different surfaces, and you can use that to, well, you get material estimates right there, which can be useful by itself. You can also build upon that and use things like cycle times to figure out how long your crew should be there. You can also use cycle times combined with rental rates to figure out how much that's going to cost. That can be based on tabulated data, or if you're lucky enough to have in-house data for that, you can use that, of course. It's customizable in our software. Yeah, so estimating, prove things like scheduling, figuring out your construction duration. Also can use it to set realistic production targets. So no one wants to give your road builders something that's unobtainable. People get discouraged when that's the case, and you also want them to be motivated though, so you don't want to be too lenient. Having something that's realistic and achievable is certainly useful. So we talked about the costing. Our software has costing function built into it. So if you were doing it by hand, it would be pretty tedious, always checking how much a different option is going to cost you. There is costing function built into it, so we can assign our different ground types for what we're building our road through, and we can have different unit costs associated with that. So we can say gravel is going to cost $12 a cubic meter or a cubic yard to excavate. To place it, it's going to cost $4 a cubic meter or cubic yard to place, whereas something like solid rock, where you're drilling and blasting, might be 2 or 3 times that. Customizable for the individual material. Then we consider the movement costs. We can assign different costs for hauling and loading and figuring out which category makes sense for certain distances, and that cost is going to be included in the costing function of the software. So that last 2 dialog boxes are where we customize it in the software, and then previously shown, we've got this Project Explorer window where we can see our costs as we explore our different design options. So now that that qualitative process is turned into a quantitative one, we know the cost drivers, the fine folks at Forestry have created an optimizer. So turns the design process into a semi-automated one where you can use the software to figure out the mathematically optimal alignment to get from point A to point B. So in previous RoadEng versions, there's just a vertical optimizer in there. So it's going to figure out, you click in the horizontal alignment and it can figure out the best vertical alignment given the constraints you put in to minimize cost. Now in version 9, there's also a horizontal optimizer, so that'll look at the whole process from 3D perspective. It'll move your plan view or horizontal alignment over, and also figure out the best vertical alignment all simultaneously. So pretty powerful, pretty cool. I do think that's kind of the future of road design. I think that's going to especially play a part once things like RTK-equipped GPS equipment become more common, and you can have your dozer operator, for example, driving along and their blades automatically adjusting to match that design surface. So that leads us into our outputs. If you had RTK or a DPS-equipped machinery, you're probably going to be giving them a land XML file, so a surface file. We export that. That can be used for slope staking if you're using a total station or RTK as well. And then if you want to share your data across other software platforms, we can export things like shapes, DWGs, DXS, CSVs, etc. So yeah, there shouldn't be issues with compatibility. Output sheets, so we've got a design here. Software is geared to make it really easy to create a formatted design. You just kind of set up your template that you want. You can be as customizable as you want and save it, and then on future jobs you can bring that layout in as a template and then matter of a few clicks, you can have a formatted drawing. I think one thing is, and if you're paying attention to the comments for why a lot of roads don't get designed in flatter terrain, there's this conception that you only need steep, gnarly, complex terrain to really justify it. It is very easy to come up with a design. I think there's value in it, so I'm going to switch over and do a show kind of how the software behaves first, then I'll do a quick demo. So let's grab this one. So this one's a design that I've put together, make-believe project. Both the projects that I'll show are make-believe projects. We've got an existing road. Of course, we've got the 3D view here, and there's no ditch on the existing road. So if we wanted to ditch that, we can just very quickly click in an alignment, both plan, profile, get it to match up, and we can see, okay, so we're ditching pretty well the whole way. We can keep track of the materials that we're going to have to move. So in 100-meter intervals, we can see I'm excavating almost 1,400 cubic meters of material. Of that, we're only using just shy of 300 to place as fill. We are side casting a lot of that, and I've got a stripping assigned here too, so we're assuming that some of that material isn't usable, and that stripping material is being accounted for as well. So all that is being used to figure out the cost for the upgrade. So we've got a cost of just shy of 18,000. The cost drivers for that are in here. So I've got gravel, and I've assumed a excavation cost of $12 a cubic meter. So that's that. As far as the way things behave goes, it's really easy. You can just grab your curves and move them around. I've got curves butted up against each other there, but we can see that. It's updating in my other views. Oh, I moved it in too close. Of course, that's that. And we can see the software is calculating the cost to construct that. If we want to create an output sheet from this, I just click my Multiplot icon down here, and I've got one pre-formatted that I want to use. So I'm going to open a book layout, and there, I've got a pre-formatted drawing showing me what I want. We've got our Earthwork summary there, and we've got a separate chapter showing our cross sections. This might be an example where the value in the design might not necessarily be for the builder. It might be more for estimating and figuring out what that should cost, how long your crew is going to be there, etc. But yeah, still value in it. So we'll jump over, and I'll kind of start a design from scratch here. So this example that I'm going to do, it's really flat terrain. Oftentimes with flat terrain, drainage can be challenging. So I'm going to grab a shapefile. So shapefile has a preliminary alignment on it. With the shapefile, there's a PRJ that attached to it, so we know our projection. So there that is. Now I want to insert my LiDAR data. So I'm just building the surface to design from here in terrain. So this is LiDAR data. It's ASCII format. It's based off a DEM though, rather than the LAS file. So it will be on a regular grid. And there's our points. Now I don't care about showing those, so I'm just going to click off to the side. I'm going to model our surface. So let's do 25 feet for our majors. 150 is where we want to start those. We'll do 5 foot for our minor contours. We'll hit OK. So there we have our surface. We can look at what our surface looks like. Of course, it is very flat, but we'll use this and switch over to location and actually do our road design. So let's just hit File, Save As, call it Topo. Come in here, and new file. I'm going to browse that topo surface that I just saved. Now, we could either start by clicking in the alignment ourselves, but since we have that other feature in there, I want to use my proposed road feature. So that's good. Template, we can use the default. Excellent. So here we have that. Now, I've got my the line work for that was at the bottom of the world. The elevations weren't assigned. That's not an issue. We'll just go in here, delete range. Just want to delete my profile points. Come back to the start. So I'm just going to start my alignment up here. So we can see it's very flat. Now that's one of those things that makes it tricky to figure out which way the water is going. So I'm going to change my scale on my vertical to exaggerate it. So we'll exaggerate it a lot. And then we can see, okay, that's where the low points are, etc. So we'll just click something in here. Now we could absolutely do this all by hand. We could move our horizontal alignment around if it made sense to. I think things are pretty flat though, so probably not a lot of benefit of moving it side to side. We'll assign a curve. And we could start figuring out our profile. Now for this, I'm just going to go here, recost, so we can see what our material movement is. So we can see I'm running a deficit. We're in fill for a lot of it. And yeah, we're not going to generate enough material to build that road locally. So I'm going to use the optimal to automatically create my vertical alignment, vertical options. So here, I guess we'll back up. I'm going to set the spacing for how often the software samples. So every 50 feet, it's going to sample. And we want to use variable curves and tangents. We'll set our minimum curve length of 100 feet and a minimum curve length of 200 feet. K values, we'll use 40 for both of those. And I think that's enough. Of course, it's the same drivers for cost as we previously talked about in the other example. Constraints, we could put a bunch of constraints in here, but I'm just going to do this for now as an example without more constraints. So I'll hit OK. And I'll come down here, vertical optimization, process. This is probably going to take a minute or so to figure out. So right now, the software is doing the sampling to generate the alignment. Now it's into the optimization side of the software. So it's narrowing down what's the optimal solution given our horizontal alignment.
And probably a great opportunity if you've got a question about something that we've seen so far, we can start to put those up into the question panel so Matt can address them at the end.
Yeah, I think it's generated there too. So, and there we are. So we have an optimal solution. We can see that. Now this, we're very close to balanced. We've got 25-ish cubic yards that we're short. So that might be suitable. One thing with designing in flat terrain, drainage can be a concern. So here where we've got things that are so flat, of course water goes downhill. but it doesn't go downhill very well when it's really, really flat. So I've kind of taken this a step further in another screen here, and we can just kind of talk about what we've got there. So let's bring this over. So this one, I've got a separate alignment for my ditch. So here this is assumed to be your overland construction where you're end dumping material for creating your prism, so importing all your material and keeping track of where the water's going. So I used one alignment to create my ditch profile. I set it up in the optimizer to do that for me. So the settings I used, instead of using curves, I used a polyline, and I set a minimum gradient. Decimals aren't showing up there, so I had it set at 0.5. So my gradient of the ditch has to be at least 0.5%. I ran that through, and then the template that I used for my actual road alignment, so the template's where we control the geometry of our road. So I've got it set up to be an 8-foot running surface on either side and a foot of surfacing. But the interesting part here is the ditch template that I used. So I've got a ditch depth that's set at 2 feet unless we have a reference feature, and then it'll follow the reference feature. So this, we're using the reference feature tie. Oops. And we can generate a pretty good drainage plan for our flat roads as well. You can take this a step further. You can also use that to plan your off-take ditches. So here, if we look at our first road, or our first culvert, which are easy to add, we've got a ditch elevation of 227.6, and I created a separate alignment where my start is tied into that at 227.6, and I carry it away at 0.5% to get rid of it. So it might be worthwhile if you have the opportunity to put a mini excavator in there. You can ditch it away and keep your road prism nice and solid rather than having to import better material so it's free draining. Yeah, that's kind of the gist of this. We can add one in just so you can see how that behaves. Add new. Horizontal alignment, we could base it off another feature, but we're going to just click it in. Oops. And we could put it anywhere we want. So creating that actual design is really easy. Profile isn't zoomed to what we want to see right now, so I just hit the zoom to extent, and there we can see the profile of the ground where we're at. Alrighty, I'll just jump back into our slideshow. Summary, LiDAR is great. It really lets you come up with a really good plan. Even prior to going to the field, there's still value in field truthing things, but previous methods, a lot of the time you're still, when you're field truthing things, you're really trying to figure out where the road's going. With LiDAR data, a lot of the time you're just figuring out if you missed something to consider for things like geotechnical parameters. Full design, it really does, it goes quick. Takes probably a similar amount of time as the previous way you're doing it with the GIS software. And lastly, just want to emphasize, you can keep it as simple or make it as complex as you want. That can be said from the design standpoint. It can also be said for when you're handing off your designs to your builders. Oh, whoops. So if you are handing it off to your builders, you obviously get the choice of, okay, here's a drawing, you can use it as a rough guideline, or it can be something really detailed where you're making sure things are exactly where you want them to be. That's entirely up to you. That's all I've got, and let's see what we've got for.
Perfect. We do have a few questions coming in here, Matt. So our first question basically is, what is your suggestion for translating a LiDAR-based road design to the road crew on the ground who is actually building it?
Okay, well that really depends. It depends what you have for tools available, and it depends how closely you want things to match up. So I think at a most basic level would be if you're doing things ribbonless, giving them an alignment and getting them to follow it as a line for the GPS. Of course, a lot of you will want closer constraints than that, so you can flag it in. You can also, if any of you are familiar with it, you can still use a P-line for reference, so you can have your ribbon center line and give offsets relative to your ribbon center line if need be. Then if you want to go really fancy, you can use a total station or RTK and slope stake everything. Yeah, so it really just depends.
Excellent. The next question that's here is actually more of a licensing question, and I can absolutely tackle that. So is the software licensed, a subscription, or a service for fee? We have both options kind of available. We've got a rent-to-own option as well as a perpetual license. If you have additional questions on that, I am happy to address them offline. Next question here, Matt. I read online there are some watershed calculations in the software. Can you tell me a bit more about it?
Yeah, so let's just switch over. And it is in terrain and terrain modeling, tin operations, and we can figure out where the watersheds are associated with our surface. So I'm going to hit OK. That's going to take a moment. While it plugs away, is there other questions?
Yeah, we've got a whole bunch more here. They're coming in fast and furious. The next question, well, that's just doing some calculations. Can depth to water table data be used to supplement the LiDAR data?
Yep. So we don't do that in our software, but if you have that data, and I should have mentioned this as well, if you have other line work or surface data or image data, we can put that in there. You can use it as a background and make pretty informed decisions. And so you could probably export that as a TIFF would probably be the format I'd use for that.
Okay, the next question that we've got here, what is the learning curve like on Forestry software? And Matt, as a former user who's never received any formal training, perhaps you're the best person to answer this one.
It's pretty straightforward. Of course, with any software, it takes a little while just to figure out where things are at, but it is set up to be intuitive. Other computer-aided design programs, so the curve can be quite steep. It's purpose-built for designing roads, so it's a matter of just clicking around and yeah, figuring out where stuff is. Still calculating. So yeah, it's just as simple as drawing a line. Your lines are attached to each other in all the different views, and you can move that around to make informed decisions and figure out what you want to do. Building upon that, if there's still a bit of a curve there, we do pride ourselves on our support. So we're more than happy to help our clients out that are on support. Have a pretty quick turnaround for that as well. And lastly, we offer training if you really want to go into that.
Perfect. Moving along, I think we've got a few more minutes, about 5 more minutes to answer some questions. The next one here, Matt, we do P-line surveys. Can I combine those with our LiDAR?
Yep. So, of course, that's thinking about things. Let's just open up a separate one. Actually, I don't think I have anything prepared for it. But yeah, you can. So if you have a LiDAR data set and you want to combine your P-line with it, you can do it a bunch of different ways, but the The easiest one is to just use your P-line as a reference. You can get your offsets from that. If you use your stationing from the P-line. For that, you can have the road, your topo surface as one file, your P-line as a separate file, and you can reference both of those in location and version 9. You could also use other data types with the LiDAR and kind of augment your LiDAR data sets with additional points. Yeah, so you can drop the P-line data set into your LiDAR data set as well, but that can be somewhat tricky depending on how accurate things are. So if one data set's really accurate and it's a poorly done P-line survey, they might not match up perfectly.
Okay. Moving along, the next question, can the full benefits of LiDAR design be realized without GPS-guided construction equipment?
Yep, absolutely. It's that's just a matter of control. I think there's a lot of benefits, just at least even if you're just using the design as a picture to reference in the field, knowing, okay, I should be 3 feet off the ground with my finished prism here, and knowing that that makes everything work well. You've got your drainage going where you want. Yeah, it's, even if you don't have tight survey control, just having a plan that you know works is super beneficial.
Excellent. The next question that we've got, what is cell size is represented in the watershed feature?
I used, I think, 10 feet, and I think that's the big reason why things are going slow here. I probably should have went a bit larger for this, so it's calculating. It's a fairly large data set. I probably should have thought about what I was looking at before I hit run. That's part of the reason why it's going slow.
Okay, and then we'll probably do this one as the last one, and then for those of you who are watching, you're welcome to stay around a little bit more as Matt finishes off the watershed piece, but we'll close off the formal questions with the last one here, which is, does the optimizer take into consideration the start point of construction and the end point to ensure the operators minimize dirt work? And when you have multiple start point options. I think it's kind of 2 questions
Okay.
a bit there.
So that's, yeah, I think that might be 2 questions. So if you have a control point where, say, you want your road to be, your design starting at the existing road, you can put in a constraint, let's see, vertical options. We can set a control point. So the set the start of the alignment, and you can have it set at whatever elevation you want. So you can capture that way. If you're looking at the horizontal optimizer, whether it can move along and figure out the best location for the intersection if you're coming off with a spur, that's, just look at the options here. It's set up so you can't move the start and end IP, but all the turning points in between there, you absolutely can. So, yeah. All right, I think that's it, and probably just going to call it that will calculate. We'll probably throw it into the, once it's calculated, throw it into the YouTube version of the webinar.
Sounds good, Matt. We've got 1 minute left here, so I just want to take that last minute, to thank everyone for joining us for our webinar today. Great way to practice social distancing, joining us online. Softry, as you know, in responding to what's happening, we've actually enhanced our webinar schedule, and we'll also be coming out with a series of web-based training events you can also attend. So stay tuned to your email for more details. Certificates will be sent to you out before end of day today, and hope everyone stays healthy and stays well. And of course, thanks, Matt, for doing the presentation.
Thanks.
Bye, everyone.
Hi, everyone. Circling back on our catchment area calculation for drainage areas. Just I'll adjust the cell size. So let's go with 100-foot cell size and depression fill depth. I like that. Try that. Yeah, we can see the two watersheds are split up very quickly.